Hi Chem, today we're going to practice a little bit more with complete electron configurations. So I'm going to start with relatively small one, and that's going to be manganese. Manganese is in the 3D sublevel, and it has a Z number of 25. That means that I will have 25 electrons that I need to represent. That means there's 25 electrons I need to represent. Remember, I always start down here at 1s. 1s has the lowest amount of electrons. And we'll also remind ourselves that the s sublevels can hold a maximum of 2. The p sublevels can hold a maximum of 6. The d sublevels can hold a maximum of 10. And the f sublevels can hold a maximum of 14. The other sublevels are theoretical, and we're not going to concern ourselves with those this year. So I'm going to start down at 1s. I'm going to put 1s as the sublevel, and I'm going to put a 2 up here to represent that there's 2 electrons in the 1s sublevel. Next, after I get to the end of this arrow, I'm going to go down to the next arrow, which is 2s. 2s, I'm going to put 2 electrons. Now I have 4 electrons represented. Now I'm at the end of this arrow. Go down to the end of the next arrow. Now my 2p. 2p holds 6. I now have 10 electrons represented. And then 3s holds 2 electrons. Here's 12 electrons, and I'm to the end of the next arrow, which is 3p. 3p6. This is now 2, 4, 10, 12, 18 electrons. So if I was at argon, I'd be done, but I'm not at argon. I'm going to keep going. This is 18 electrons, and I need 7 more to get to 25. So after 3p comes 4s, and 2 electrons go in there. So now I have 2, 4, 10, 12, 18, 20 electrons, and I'm at the end of this. And I'm now going to be in 3D. 3D will not be full though, because this is 20 electrons and I only need 5 more. And if you notice, manganese is in the 5th position of 3D. This is how you do complete electron configurations. Now let's do a little bit bigger of an atom, and let's go to iodine, which is a halogen. An atom of iodine has a Z number of 53. So we have 53 electrons to represent. We're again going to start down at 1s. So 1s2, and then when we're done with 1s2, we go down here and we start at 2s. 2s2, I'm going to keep filling them up the way I did before. After 2s comes 2p. Now, after 4s, I'll go down to 3D like this. So let's count what we have so far. We have 2, 4, 10, 12, 18, 20. We need 20. We have 20 out of 53. So next 3D10, because we need 33 more. Now we have 30, and we go to 4p6, 5s2. 5s2, so let's count. 10, 20, 38 I'm at out of 53. So after 5s2, I'm going to go down and I'm going to fill 4d10. So now we have 10, 20, 30, 38, 48 electrons. So I need to get to 53, I need 5 more. So I'm going to put after 4D, I have 5p, but I'm not going to need all 6 because I only need 5 more electrons. So this is the complete electron configuration for iodine. You double check by adding that. All of these add up to 53. And then you can also double check because iodine sits in the 5p sublevel in the 5th position out of 6. Now I'm going to do an even bigger one. Let's pick one that is going to have some electrons in the F sublevel. I'm going to pick tungsten, W. Tungsten has a Z number of 74. You've probably all seen tungsten before. Tungsten is the metal that they use for filaments in like old-timey light bulbs. So that little metal wire, that curly Q of wire in there that glows when a light bulb is lit, is usually made of tungsten. And it's in an argon environment, usually sealed up in glass and metal. So we're at 74. I'm going to start at, let's do the 1s2, 2s2. I'm going to keep going until I get to close to the number that I'm looking for, and when it's going to get difficult, or new at least. Now I'm at the end of 5s2. So after 5s2, I'm going to go to 4d10, 5p6, 6s2. And after 6s2, here's where it becomes new. We're now going to dip to the bottom part of the periodic table, the elements, and that's going to be 4f14. So after 6s, after barium, we go to lanthanum, and that's the lanthanum series in the rare earth metals or the inner transition metals. After that, we're going to go back to the upper part of the periodic table, the elements, and pick up at number 71. And number 71 is in 5D, but I don't need all the 5Ds. So I'm going to count up. I have 10 here, 10 here, 10 here, 8. So 10, 20, 38, 48, 56, then on to 70. So once I count up that I'm at 70, I know I need 4 more, and those 4 more are going to be in the 5D sublevel, like such. And then you can double check yourself that tungsten is at number 74, which is in the 4th position of the 5D sublevel on the periodic table of the elements. This is a complete electron configuration for tungsten.